Okay, so the developer also removed, we had the other signal types there before, sine wave, chirp, pulse train, white noise. If we can bring them back,
Yes, I
that
see.
would be great. Yeah, that would be great. And also another thing is, yeah, so the animation now works for every drop down, so just varying the parameters that we have, which is good. Yeah, I don't think there's any.
Understood.
There's also in ECG signals, there's not much a difference between normal sinus rhythm and arrhythmia. So if we can check that, I don't think that's actually working. And in EEG, we want to be
So,
able to, in EEG, we want to be able to vary all the bands, all the frequency bands simultaneously. So and change the amplitude all at the same time, so we can see all of them potentially on the spectrogram. So can you turn all what we discussed so far into instructions for the developer, questions for the developer? Just keep in mind it's a highly experienced developer, so
sure. Here are some instructions for the developer. First, please reinstate the previously removed signal types, including sine wave, chirp, pulse train, and white noise. Second, ensure that the animation works properly for all selectable parameters across all signal types. Third, address the issue where there is no discernible difference between normal sinus rhythm and arrhythmia in the ECG signal type. Fourth, for EEG signals, implement the functionality to vary all frequency bands and their amplitudes simultaneously on the spectrogram. And finally, ensure that the changes are seamlessly integrated and the application remains stable.
wow, that's pretty good. What's the developer's thinking process?
Based on the instructions, the developer seems to be focusing on refining the user experience and expanding the functionality. They're aiming to make the application more intuitive and educational by incorporating smoother animations, restoring the removed signal types, and ensuring the accuracy of the ECG signals. Additionally, they're adding a feature to simultaneously vary EEG bands, enhancing the application's capabilities for analysis.
Okay, what else are they doing? What else the developer is doing at the moment?
It looks like the developer is also updating the code structure and re-implementing the signal generation functions. They're making sure the application remains stable and that all the animations work smoothly with the new signal types. They're also ensuring that default parameters are visually distinct for a better user experience.
Again, can you review the code real quick as well?
Based on the code snippets visible, it looks like the developer is using HTML for the structure, CSS for styling, and likely JavaScript for the interactivity and signal generation. They seem to be using specific elements like sliders and dropdowns for user input. The code appears to be organized, but a more comprehensive review would be needed to assess its efficiency and potential issues.
Okay, there's one problem, as you can tell. What do you think the problem is? It's the Y scale of the frequency. Um,
Ah, I see. It looks like the y-axis of the spectrogram, which represents the frequency, isn't displaying the different frequency bands clearly for the brainwave signals. It's not showing the individual delta, theta, alpha, and beta bands distinctly.
I think it is. It's just the scale of the chart.
That makes sense. The developer might need to adjust the scaling of the y-axis on the spectrogram to properly display the different frequency bands for the brainwave signals, making them clearly visible and distinguishable.
Okay, and can we also fix the frequency and time labels on the chart and the axis? Do we need to add axis?
Yes, ensuring that the frequency and time labels on the spectrogram are accurate and clearly displayed is crucial for the user's understanding of the data. The developer should make sure these labels are correctly aligned and easy to read.
Do you think we should have some controls below the spectrogram chart?
Yes, adding controls below the spectrogram could enhance the user experience. This could include options to adjust parameters like the frequency range or time window displayed, or even playback controls for the signal generation. It would make it easier for users to interact with the visualization.
Wait, so we have these controls already under the frequency spectrum chart. Should we just have controls over the scale, the axis, the scale of the axis, but then the web application should automatically pre-select those when changing different signal types and things like that. So can you explain it properly?
Sure, the developers should keep the existing controls below the spectrogram chart, but focus on enhancing the control over the scaling of the y-axis to ensure the frequency bands are clearly visible. Additionally, the web application should automatically suggest the optimal scaling for the y-axis based on the selected signal type and parameters, providing a seamless and intuitive user experience.
Okay, it's actually pretty good. It's pretty good as is.
Great! So it sounds like the core functionality is working well, and the suggested changes will further improve the application's usability and clarity.
Yeah, so the X, Y are good, but yes, we would like to make them better. We'd like to fix the we like having some controls on definition. So, for example, log scale, not log scale, switch below the spectrogram chart, and also the range, which will be indicating what's automatically is being selected uh, by the web application, by the algorithm. Did you get that? Yeah, I'm having issues with the... Anyway, I really like this web app. It's really nice. It's really nice. We lost the prompt engineer. We lost the prompt engineer. That's not fun. Yeah, I'm not sure how accurate the eye blink is. It's varying it randomly, which is nice. Which is nice. Can you quickly explain what do you see on the screen?
I see a tool called the Interactive Spectrogram Generator. It looks like it's used to visualize EEG signals, probably for brainwave analysis. You can adjust different settings, like the signal type and frequency bands, and see the spectrogram change in real time.
Okay, that's nice. Now for the EEG, for example, what's the problem with the chart, particularly the Y and X axis?
The y-axis in the spectrogram represents frequency, and the problem is that it's currently displayed on a linear scale. This makes it difficult to see the lower frequency bands, which are often important for EEG analysis. The x-axis represents time, and it could be improved by adding more detailed labels and better dynamic updates.
Wait a sec, can you double check, is the frequency linear or logarithmic scale at the moment?
It's currently on a linear scale, and the suggestion is to switch it to a logarithmic scale.
It's logarithmic scale at the moment, can you double check?
Apologies for the mistake. You're right. The frequency axis is currently on a logarithmic scale. The suggestion was to use a logarithmic scale, which it appears to beacon already.
Okay, how would you improve the access and the display? And we would like controls under the spectrum chart that will indicate the current settings. So the range of X and Y, and if it's logarithmic or linear.
To improve the display, you could add controls below the spectrogram to indicate the current settings, such as the frequency range and the scale used, logarithmic or linear, for the y-axis, as well as the time span displayed on the x-axis. This would make it clearer for users to understand the visualization.
Okay, but also how do we make sure, that those controls are varied automatically by the algorithm, depending on which signal type is selected?
Yes, you can design the controls to automatically adjust their values based on the selected signal type. For example, when EEG signal is selected, the frequency range can automatically be set to typical EEG bands, and the scale can be set to logarithmic. If a different signal type is chosen, the controls can display the appropriate range and scale automatically.
And how do we make sure that the y-x axis, the number on the axis and the label of the axis look correct, appear correctly?
To ensure the axis labels and numbers appear correctly, you can use dynamic label generation in your code. This way, the labels and tick marks will be updated automatically based on the selected signal type, frequency range, and time span. You can also use formatting techniques to make the labels readable and prevent overcrowding on the axes.
And currently we have general signals. Then within biomedical signals we have EEG, two types of ECG, PPG. What other signals would you recommend adding?
Besides EEG, ECG, and PPG, you could add signals like EMG for muscle activity or EOG for eye movements. These are common signals used in biomedical research and could provide a more comprehensive analysis in your tool.
Also, within the ECG, so in the dropdown, we currently have both ECG normal and ECG arrhythmia. Do we need can we have the abnormal ECG to be, so in the signal type dropdown, only have ECG, and then within that, the control should then have an option to select between normal and abnormal ECGs. Can you explain that properly?
Yes, that's a good idea to consolidate the ECG signals. You could have a single ECG selection in the signal type dropdown, and then add separate control, perhaps a radio button or another dropdown, below to specify whether it's normal or abnormal ECG. This would make the interface more organized and intuitive for users.